The majority of Anthropocene extinctions point, I think we all agree, to the sort of blundering, inadvertent quality of human agency. The anthropos of the Anthropocene, which I think needless to say, but also needful to say, is of course not equally constituted by all humans, is more of a dumb force than an intelligent agent. I certainly feel like I'm part of a dumb force. No one, after all, meant to devastate frog populations. No one meant to drive polar bears to starvation. No one meant to introduce deadly Ascomycete fungus to bats. And yet here we are. Bruno Latour, speaking of climate change, but he may as well have been speaking of the current extinction crisis, has asked how Western civilization could simultaneously be part of such a long history, have such an important influence, and yet be so late in realising what has happened and so utterly impotent in our attempts to fix it. His answer, of course, is that the active role and agency of Western humans in the extinction, well, in the Anthropocene, I'll say the extinction crisis, isn't generally agency with its commonly understood valency of intentionality or authorial control. Our agency has been, for the large part, instead been unwitting and inadvertent. In Latour's formulation, Western humans are subjects subjected to the vagaries of their own interconnected collisions. Well, I agree. One of the most common gestures adopted in our mainstream media as we see that yet another species is, as Anna put it, an ex or a post-species. Thanks, Anna. That's a very useful locution. Is the gesture of disarmed, horrified surprise. The whoops gesture, the we didn't realise our own strength gesture, the we didn't mean it gesture. Contemporary extinction is repeated proof of our feckless agency. But against that, there is a relatively small number of effective extinctions that people have deliberately authored and authorised that seem to contradict this general picture of blundering, inadvertent destruction, and that are celebrated as evidence of the anthropos's, particularly Western civilization's collective power over nature. These planned extinctions are largely of species that have had long, intimate relationships with humans, not necessarily the same humans that authorised their destruction. They're the extinctions of species that have figured importantly in human cultures. The smallpox virus, which people in Asia, Africa and Europe, and eventually the Americas and Australasia lived and died with for perhaps 12,000 years, is of course the poster child for planned extinction. A systematic international vaccination campaign through the 20th century has deprived smallpox of its host environment, the human body, all around the world for over 40 years now. There are likewise discussions about eradicating the Anopheles and Aedes mosquitoes, which represent 30 of about 3,500 mosquito species, and the extinction of which would save people, ideally, from malaria, dengue fever, yellow fever and elephantiasis, and the parasites that cause those diseases would most likely become extinct at the same time. In this paper, I'm going to focus on an international attempt led by the Carter Centre in league with the World Health Organization to destroy Dracunculus medinensis, perhaps better known as the Guinea worm. And if you know anything of it, you'll know why I have no slides today, because I, as a kind of confirmed helminthophobe myself, despite my better instincts, I find it quite hard to look at. The superfamily of Dracunculoidea are best known for the fact that as adults, they live in the tissues and serous cavities of mammals, fish, reptiles, amphibians and birds. They are, in other words, animal parasites. Of all the Dracunculoidea, Dracunculus medinensis has received the overwhelming share of attention because of its dependence on human hosts, with whom it has lived and co-evolved for many thousands of years, perhaps the entire Holocene. In 1986, there were around 3.5 million confirmed cases of dracunculiasis, which is a condition that results from the Guinea worm maturing into its adult form inside its human host's body, and by this stage about 1 metre long, burrowing out of its host's skin, usually at a lower extremity. Just cover your ears if this is troubling you, generally causing terrible pain over several weeks as it talks around nerves, and sometimes resulting in permanently disabling or fatal secondary infections. If you want more evidence of how terrible this can be, the Carter Centre, which has been leading its eradication, has a slew of videos of really, really unhappy people experiencing the emergence over a period of perhaps 10 days of the worm. In 2017, the 3.5 million annual infections was down to about 30 reported cases. So Dracunculus medinensis was well on its way to extinction, a state in which it hovers as we speak. From the stance of the medical sciences and human welfare campaigners, this is of course an outcome devoutly to be wished. Because of the nature of its life cycle, in the 20th century, dracunculiasis has overwhelmingly targeted the rural poor, often children, in sub-Saharan Africa. In longer historical terms, it was far less discriminating in whom it infested, and it spread from sub-Saharan Africa to the Mediterranean to India. And in fact, in the 19th century, there are a couple of cases of dracunculiasis occurring in Australia, mostly people who had travelled recently through India. So it is but for the grace of the privilege of those people who were able to access medical attention that Dracunculus didn't become endemic in Australia. The Rod of Asclepius, which you may know as the symbol of pharmacological medicine, the stick with the snake-like creatures winding around it, has been conjectured as a symbol of the first, or one of the early medical procedures, which was the unwinding of the guinea worm as it extruded itself from its host's skin. So it has a long and rich history with humans. But what is significant for its 20th century history is that the hosts of Dracunculus were by and large disproportionately unequipped to access resources for pain management and to mitigate the social and health impacts of potentially permanent disability. So it is no surprise that the overwhelming stance towards Dracunculus has been one of an unalloyed antagonism. While this is a position that I fully understand and intuitively share as a sort of individualist, Western, hygiene-centric person, in this paper I want to test this position against the ethical arguments of bioconservationists around extinction, arguments both about the intrinsic value of species and about the utilitarian value of biodiversity in stabilising ecosystems, promoting the greater well-being of its constituents as a body. But in particular, I want to signal my worry about international planning against a species in an era that has repeatedly thrown in our faces how terribly poor we are in foreseeing and controlling the outcomes of our hugely impactful, scaled-up actions. In the face of the compelling humanitarian argument for eradicating Dracunculus, all inquiry into its possible contribution to an ecosystem, or indeed possible health benefits to its hosts, have been shut down. Maybe there are no such benefits, but maybe there are. Our position of unalloyed antagonism towards the guinea worm has meant both that it's been targeted for eradication and that its targeting has taken place in the light of drastically limited insight into its ecological relations. The eradication program itself has been a thing of uncanny elegance, largely operating through two simple changes to people's behaviour. The first of these is to encourage people to strain their drinking water through something as simple as a cloth. The Dracunculus larvae inhabit an intermediate host, the copepod or water flea, and simply by draining the water fleas out of the water source, people can avoid infection with Dracunculus larvae, and thus the guinea worm is not able to grow to adult size in their tissue. The second expedient, and this is if somebody has dracunculiasis, is to encourage them not to take their painful infected ulcer into a water source. So not to take their foot into the water to relieve the pain with the coolness, where the worm could shed its segments into the water and continue its life cycle. And through a very well-resourced education campaign, these two behavioural changes have been pretty successfully effected, as you can tell from the decline in instances of dracunculiasis. It's hard to see this as anything other than a good thing. Knowing as much or as little as I do about dracunculiasis, I wouldn't volunteer even the most egregious of Australian immigration ministers to host the poor little guinea worm. The worms can cause immense pain, morbidity, in some cases mortality. Sometimes permanent disability can impair people's social participation for the rest of their lives. Outright antagonism is understandable. In 2003, Olivia Judson advocated for the extermination of the 30 mosquito species I mentioned through genetic manipulation, arguing that this loss would be trivial compared to the continual extinction of other species we perhaps actively value. She claimed in her New York Times article of that year, "We're not left with a wasteland every time a species vanishes. Removing one species sometimes causes shifts in the populations of other species, but different need not mean worse." In other words, the planned extinction of a small number of pests is a negligible issue in view of the scale and dynamics of the speciation and extinction processes in the evolutionary history of the Earth. That is a point, so why not eradicate the Guinea worm? Arguments for the mitigation of species extinction usually take two forms. One concerns the intrinsic value of a species, and I regret to say that in public policy realms, the compellingness of this argument often depends on the biases of the people listening, so that the supposedly intrinsic value of a charismatic, cute, or otherwise culturally significant species often registers in ways that a less charming species could not hope for. In the West, 250 years of taxonomic discrimination against fungi, invertebrates, and microscopic organisms means that the intrinsic value argument is likely to have significantly less heft in advocating for the vast majority of parasitic species. And we can thank renowned mycophobe Carl Linnaeus in part for that. Just as an example of that taxonomic bias in action, Alison Pulio has noted that Australia's Environment Protection and Biodiversity Conservation Act, our main piece of conservation legislation, mentions 2,000 species of plants and animals and just 2 species of fungi, and worse, that the 2 fungi it mentions are described as threats to biodiversity rather than as vital citizens of ecosystems endangered by our mostly drying climate. So the intrinsic value of species argument, especially when it is so inflected by human capacity or incapacity to see the intrinsic value, is going to be all the less persuasive when discussing a parasite of humans, particularly a parasite that generates immense human suffering. And it's of course not important in the guinea worm's case that the suffering is disproportionately affecting people who are not well resourced to mitigate pain in the short term or social disadvantage ensuing from disability in the longer term. In this kind of situation, I think the intrinsic value argument struggles to stand up. The second kind of argument that often features in species conservation discourse is a utilitarian one. In their chapter on parasite conservation, conservation medicine and ecosystem health, Andres Gomez, Elizabeth Nichols and Susan Perkins argue that parasites are, quote, a diverse suite of organisms that threatens the health of individuals and populations, but is nonetheless critical for maintaining healthy ecosystems. Parasites are ubiquitous. There are more parasite species than non-parasite species on this planet. And as Gomez and co say, their effects on the overall functioning of ecosystems are complex and often positive, but until recently, within the field of ecology, parasites have been overlooked as unimportant to the maintenance of viable ecosystems, perhaps due to their cryptic nature, intractably high diversity, small size, patchy distribution, and a general lack of observable morbidity in nature. These are all likely reasons for the ignoring of parasites, but I would argue also that our willingness to look at parasites as potentially beneficial to the stability or function of their ecosystems is also in large part because of the cultural resonances of this term parasite in Western individualist culture. The parasite, from the Greek parasitos, which literally means something like getting food on the side, initially meant someone, a human, who comes to your table and eats the food that you've worked for without paying for it. It's a word that has been in English used for a much longer time to describe human behaviour than it has non-human behaviour. In fact, the word parasitos was used in ancient Athens, but in the 16th century in English, it was used to describe someone who lives on another man's trencher, if you like. The biological sense of the word doesn't kick in until the early 18th century, when botanists started to discuss parasitic plants. So we have a good 2,000 years of derogatory discussion of parasites as nothing other than a drain on their hosts' resources and health. And this, I think, has also prevented us from entertaining the possibility that in some larger ecological sense, some parasites at least may, in fact, pay for their food and lodging. Perhaps not a payment made directly to their host, although perhaps, but certainly a payment made to the larger system in which their host exists, and the stability of which is ultimately beneficial to the persistence of the host species. There is undoubtedly a utilitarian argument to be made for some parasites, but it is difficult to make when the ecosystem role of parasites is so under-researched. All many people can see is that to conserve parasites is to explicitly conserve morbidity and mortality in their host populations. I have a third argument against planned extinction, which is really going back to my critique of intentionality in the Anthropocene. We do not know our own strength. This is, if anything, the lesson of the Anthropocene. The outcomes of our actions vastly exceed our intentions. And this is particularly the case with a species that has only been studied from a perspective of outright hatred. The possibility that it might have ecosystem stabilising effects has simply not been considered, for the most understandable of reasons. In the wake of the Guinea worm's progress to extinction, unexpected behaviours have been coming to light. 2 domestic dogs have been found with dracunculiasis, a condition not previously recorded in dogs, although that may not necessarily mean that it's new to them. What other mammals could be affected or could have been affected by dracunculiasis? We don't know. Meanwhile, a number of new potential intermediate hosts have been discovered. Tadpoles of a certain species of green frogs were found to harbour small numbers of Dracunculus larvae, a fact that was not known when the eradication campaign began. 2 ferrets were fed the tadpoles that had been exposed to the infected copepods, and at necropsy 70 to 80 days later, they were found to harbour Dracunculus larvae. So the capacity of this parasite to infest other species is unprobed, very interesting and quite significant for the role that it may have been doing in ecosystem stabilisation, but we don't know. Besides their ecosystem stabilising work, some parasites have also recently been discovered to benefit their hosts. Recent immunological research has presented the thesis that contact with parasites and non-pathogenic organisms might, quote, modulate the immune system's response to pathogens and allergens. Studies suggest that contact with saprophytic bacteria and parasitic helminths, i.e. worms, can reduce the risk of immune-mediated disorders such as inflammatory bowel disease and asthma, diseases that are on the rise in developed countries where human parasite exposure is strictly policed. The line between parasitism and symbiosis or even mutualism is much more porous than we have allowed. Finally, if the principle of species conservation is allowed exceptions where certain species injure human interests, then where do we draw the line? The thylacine, which Tom mentioned at the beginning of today, was a species that in a sense injured certain humans by preying on their livestock. And it too was eradicated in a kind of planned extinction, perhaps not quite as organised a one as the Carter Centre's Dracunculus extinction. To what ecological effect? Well, we don't exactly know because its ecological role was also under-researched. And it's the fact that where our relationship to a species is one of outright antagonism, we're much less inclined to investigate their beneficial role, we're also much more likely to engineer an extinction, the effects of which we're badly placed to anticipate. That's the end of my paper.